pre-calc students, day 6 of Unit 2, more inequalities. We're going to do all 3 types. The absolute value inequalities, the quadratic inequalities, the rational inequalities that we just did yesterday. As a quick warm-up, we're going to solve this quadratic inequality graphically. We said we're going to set it to 0, so we can use the one graph method. 7 minus 3 is plus 4, less than 0. Plug that baby in. Y equals x squared minus 2x plus 4 and hit graph. Ooh, what does that mean? There are no roots, there are no partitions. If I turn that graph into a plus minus line, it's always above, it's plus. What do I want? I want the negatives. There are absolutely no negatives, no solution. If that, on the other hand, said greater than 0, all real numbers. Everything would work in that inequality. In this case, no number would work to make that true. All right, the example we just left off at the end of day 5, we didn't finish. I said, hey, let's take an analytical approach to this one instead. 8 over x minus 2x greater than or equal to 0. I know that. Set it to 0. We do that a lot. Rational inequalities means common denominator is one fraction. 8 minus 2x squared all over x greater than or equal to 0. Numerator, root. 8 minus 2x squared equals 0. I label it. Denominator restriction, that's kind of easy. I'm going to do that one first. 0 is one of my partitions. How do I solve this? Pull out a 2, leave you with a difference of 2 perfect squares. I have 2 solutions here. So if I've got 3 partitions overall, I've got 4 regions. Left of -2, between -2 and 0, between 0 and 2, and greater than 2. What am I going to do now? I'm going to pick a number in each interval, -3, -1, 1, and 3, and I'm going to plug them into this nice fraction right there. Again, I can do it long way. 8 minus 2 times -3 squared over -3. -3 squared is 9 times 2. 8 minus 18 is -10 divided by -3 is a positive. And I know that rationals always have sign changes. So if I plug the -1 in, I'm expecting it to be a positive. I'm sorry, negative. 8 minus 2 is 6 divided by -1 is negative. Yes, it is. Plug it in. 8 minus 2 divided by 1 is positive. Let's go over here. 8 minus 2 times 3 squared over 3. Well, we knew that that top number is going to be negative. The bottom number is going to be positive 3, so that is indeed negative. What do I want? I want the positive regions. I want the first region, which is x. I'll do it right here. X is less than -2, or it's between 0 and 2. I never put the equals on until the end. Here's why. It is equals, but we can never include the restriction, which was 0. That one gets that one doesn't, that one gets that. That's our solution right there. A rational inequality analytically. Let's read our directions. Solve the following absolute value inequality analytically and support it graphically. All right, we can do that. So what do we got analytically? Let's go back in our notes. We said 2 equations. Negative right side, positive right side. Again, I'm just trying to solidify these in my brain so I can do them on my own. Add 3x, I would get 12 equals x. That looks good to me. Add 3x, divide by 5, x equals 12 fifths. I'm going to call it a decimal because dividing by 5 is nice. 2 and 2 fifths, otherwise known as 2.4. So I now have a 3-region number line. 2.4 is smaller than 12. Looks like that. I go back to my absolute value, and I have to do this. So I have have something to plug it into. Give me a number over here. I love it. 0. How about 5? And how about 20? And if I plug it into the blue absolute value, again, I'm going to go slow. If you guys get good at it and go quicker, good for you. What do we got? 12 minus 3 times 0 is 12. Absolute value of 12 is 12. Minus 0 is a positive. Now remember, absolute values may not have a sign change. So you got to be careful here. Plug a 5 in. 12. 3 times 5 is 15. 12 minus 15 is negative 3. Absolute value is 3. 2 times 5 is 10. 3 minus 10 is a negative. Well, we got a sign change there. And then we plug a 20 in. 12 minus 60 is negative 48 times, or positive 48 absolute value. 20 times 2 is 40. 48 minus 40 is positive. So, there are instances where that X on the right side does not mean no sign change. If you were thinking about it, if you said, you know what, I like math, I like the challenge, here's why. The slope of the right side is 2. The slope of the left side is 3. It's only when this slope over here is greater. If that was a 4x, that would make my v skewed enough that there would be no sign change at one of the two places. But this time it is, so we're just going to get our solutions. What do we want? We want negatives. We want the region in the middle. We want all numbers between 2.4 and 12. And it's equal to, and these are both inclusive. There's our solution right there. An analytical absolute value. Let's now solve the graph. We're going to go one graph method. We're going to use that nice blue inequality that we got. Y equals clear. Math over num. Enter. Absolute value of 12 minus 3x. Let's get out of there. Minus 2x. Now I'd expect 3 regions, so I'd expect the v to hit 2 times. Let's see. Zoom 6. Nice and centered. Not centered enough, but it looks like it's going to hit. What do I need to change? My window and my x max has to go up from 10. I'm going to go 20. See if it's enough. It sure is. Graphically speaking, I would sketch that. It's a skewed V. Looks like this. It has 2 roots. I can use my calculator. I'm going to use a table to find the first root, because I'm pretty sure 12 is going to be a 0. There it is. And then I'll use the calculator itself, second calc. I don't know if I put the 0 in or not. I think I did. Let's put 5. Darn it, I didn't. Y equals, let's go down to 0, Y2. Second calc 5. Get that spider over here. Enter, enter, enter. I'm pretty sure it's going to be 2.4, and it is. And again, it's graphical. Translating that graph to a one-dimensional plus-minus line. Above, below, above. I wanted negatives. So I'm going to pick this region right here. Inclusive. Does that graphical match up with the analytical? It most certainly does. All right, so we did a rational today. We did an absolute value. Let's do a quadratic. And then we'll come back and we'll do a rational. Got about 9 minutes in. Each one does about 15 minutes of a video. We'll save that one. Let's go to, hold on a sec. There's my example 7. Oh, that's all right. We'll put it on right now. Example 7. X squared minus 2x less than or equal to 3x plus 32. I'm going to solve it graphically first. Subtract over the 3x, subtract over the 32. We have that. Let's plug that into our graphic calculator. Nice happy U. Leave the 0 into y2, clear that out. X squared minus 5x minus 32, zoom 6, just what I thought. Nice happy U. Both roots are on my screen. Why did we practice finding roots a couple days ago? For this exact reason. Second, calc 5. Spider is closer to this one. Here it comes. Enter, enter, enter. Negative 3.685. And let's find the other one. Let's move the spider over. Chase along the line instead of the curve. Maybe it's quicker. I gotta keep tabbing. Close enough. Enter, enter. Intersection 8.685. Plus minus line. That number above, below, that number. What do I want? I want the belows. So what are my solutions? X, any number between this and this, and it's equal to, so I can include. Question: what do you think we would have done analytically? Answer: we would have attempted to factor that. It is not factorable. We would have had to use a quadratic formula. So let's just do that part if we were going to do the analytical. Again, another tool we practice to make sure you're good at it. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. What's that give us? 5 plus or minus. I did that arithmetic already. Negative 5 squared is 25 plus 128 plus, because the negative times the negative is radical 153 all over 2. When I do this one, 5 plus radical 153 over 2, I get 8.65. When I do the minus, I get this. Exactly the same answer. We can do a plus minus line from the green, plus minus plus, test intervals, and get the same answer. When analytical matches up with graphical, right on the money. All right, so that was a quadratic. Let's go back and we'll do one more rational. How about this one? Example 6. Rational technique. Oh, I remember. X over x minus 6 minus 4 greater than or equal to 0. X over x minus 6 minus 4 x minus 6 over x minus 6 greater than or equal to 0. I'm going to skip a step here. You guys are smart. X minus 4x plus 24 all over x minus 6 greater than or equal to 0. Clean that top up. Negative 3x plus 24 over x minus 6 greater than or equal to 0. I got one fraction. Quite a bit of work. I am now going to do root. I like to label. Subtract 24. Divide by negative 3. My root, my x-intercept is 8. Restriction, pretty easy. Plus, minus line. 6, 8, left, middle, and right. I like this one right here. Let's plug 0 into there. 0 plus 24 is positive 24. 0 minus 6 is negative 6. A positive divided by a negative is, is a negative. That's what that little mini fraction is. Let's try 7. Negative 21 plus 24 is positive. 7 minus 6 is positive, which is positive. And let's try 8. I'm sorry, can't try 8. Let's try 9. Negative 27 plus 24 is negative 9 minus 6 is positive, a negative divided by